The date is February 12, 2021. Been doing a bit of research and looking up pictures of viruses, and I'm getting a wee bit frustrated because I can't find a proper picture of a virus, because the pictures we have are through electron microscope, which is like a CGI machine. Whether it works the way they say it works with electrons and beaming down and getting a picture quality, there's been a questions that are not really making sense to me. So this video is just trying to research some of the questions that I have. This first video is about a scientist that has some of the images on Google. These ones you can look up, so it's quite interesting whether you believe it or not. So here we go with this video. Bow.
Yes, so that's how you pronounce it. Okay, that's a good start.
And the other is Beth Fisher. Her team at NIAID, the National Institute of Allergies and Infectious Diseases, created those initial images of the virus. The ones you'll start to notice embedded.
You notice that the man said created. Electron microscope produces images through electrons that are shot very fast, and they're able to produce these images through these special cameras. So no one has ever seen a virus through the naked eye, because that is impossible. They are too small. But you can take a protein from a virus and put it in a vaccine.
Mystery to this virus as there are to other viruses that emerge.
So let's start with how these images were made. The first thing you need to know is that the coronavirus is very, very, very small, around 100 nanometers. To put that into context, if you take out a ruler and look at one of the millimeter markings, you could fit 10,000 virus particles inside of that. At that size, it's invisible to us, even under a standard light microscope like the one you might have used in grade school. That's because the smallest wavelengths of light humans can see measure around 400 nanometers, not small enough for the coronavirus to be visible. In order to see something that small, you need an electron microscope.
How does it actually differ from what we would think of as a microscope?
Instead of light, we're using electrons, and electrons you think of as particles. But if you take the electron, strip it off of the atom, and accelerate it in a field and make it fly really fast, if you make it move fast enough, it actually will behave as a wave as well.
And that wavelength is much, much smaller than the light waves we use in a standard microscope.
So now you're like 6, 7, 8, 9. Magnitude smaller in size. So now you can see smaller stuff.
If you look through NIAID's coronavirus Flickr page, you'll come across two distinct types of images, SEM and TEM. They're made using two different types of electron microscopes. A scanning electron microscope, or SEM, scans the surface of a sample and records what bounces back, sort of like how satellite imaging works. It gives you the basic topography of whatever you're looking at, with realistic lighting similar to photography. Shadow and relative size of objects shows you their placement and how they move through the cell. A transmission electron microscope.
Did he just say shadows? How can you produce a shadow with electrons beaming off something? That should produce the image. No shadows.
Images from both microscopes are taken in black and white. The color is added later for clarity, like in this SEM image, where virus particles, colored in yellow, are seen emerging from the surface of a cell, colored blue and pink. When examined together, these images can help scientists start to figure out how the coronavirus works.
There's ways to start then understanding how is it getting in a cell, how is it harnessing that cell machinery to make more of itself.
Can you just tell me kind of what we're looking at here?
So this is a single viral particle, and the yellow you see is the core of the virus itself, and then the corona, where coronaviruses get their name, is sort of that halo around it that's in orange.
That corona is the key to understanding how the virus hides.
This image here looks very CGI. So does a lot of the other images. And a lot of virus images that you look up on the internet, a lot of them look similar. My question is, seeing that we can only get pictures of so-called viruses through electron microscope, how can we produce a spike protein in a vaccine? Here are some images of the flu and COVID-19. It's hard to know which ones are different. They seem to be one and the same. But maybe not. We can change up the colors to make them look a wee bit different. This is part one. Part two will be about the vaccine.